Hi, everybody. My name is Sharon Strover. I'm from the University of Texas, and I am recording a very brief video to give you a guided tour around our poster on some ongoing research. This project is called Ethical Data Design, and it is really focused on looking at some natural hazards data processes with a view to understand what in those processes has some bearing on future uses of data, particularly in an artificial intelligence and machine learning environment. We're especially interested in that because the data generated around natural hazards and natural disasters is voluminous. And a lot of researchers are intent on figuring out ways to process that data, especially visual data, for machine learning purposes. As machine learning and AI get more powerful, these offer terrific ways to process these kinds of data, especially in the context of the time pressures that a lot of disaster-related data face when people have to answer questions very, very quickly in the case of ongoing disasters. So to make a long story short, we've compressed a year's worth of work in one poster. We're still not quite complete with our data gathering and analysis, but I'll tell you a little bit about what we've been up to. Basically, we're looking at these ethical tensions that arise in the context of gathering and sharing natural hazards data using repositories with a view to AI and machine learning language. We have done two primary things for this conference purpose. One, we unpacked some of the analyses pertaining to Harvey data. We're from Texas. Harvey is still a very fresh memory, and there has been a lot of data generated around the damage associated with Harvey. Second, we've done a series of semi-structured interviews with people who have developed data around natural hazards, who have run repositories, who manage data repositories, and who generate large data sets that find their way into these repositories. All of the data that we're examining has to do with natural hazards in some way, shape, or form. So you see in the middle column of our poster are key questions, which concerns identifying the ethical tensions, the ethical features that come up as we consider the issues facing data producers, facing the repositories, the platforms in which the repositories reside, and of course the users themselves. And then secondly, we're looking at how the ethical features can be managed. And we look at management in terms of the data lifecycle, which I'll turn to momentarily. And then third, we're looking at the kinds of techniques that might be helpful in identifying and tracking ethical features used in data. So I mentioned the data lifecycle as we're using it in question number 2, and we have a little graphic here of the way we're conceptualizing data life cycles, particularly in the context of artificial intelligence. We conceptualize data not simply as those information points that people collect around natural hazards efforts, but rather we incorporate all the planning that goes into designing the kinds of data one thinks one needs and how one will gather it, those collection processes that include the sources people use, why they made the decisions they did to use particular sources, unforeseen uses in the collection of that data. We consider what's discarded, what is kept, and how those data are basically manipulated as they move toward becoming data sets and databases. We're especially interested, as I said before, in where artificial intelligence intersects the data lifecycle. AI depends on data, and AI routines are typically applied to pre-processing data in order to understand its structure, test validity, and work out the algorithms that are then applied to complete data sets in order to actually process that data and come up with workable algorithms and workable routines to deploy the data. These are cases where the provenance of the data gets lost, frankly, and we're keen to kind of unpack how data provenance can be maintained in AI processing phases. And then finally, of course, one of the big missions of data repositories is to disseminate that data. And most people receiving funding, such as from NSF, to gather natural hazards data are obligated to put those data into some kind of a repository in order for other people to use that data. So how the data can be disseminated, how target audiences are identified, thought about, defined, and understood by data producers is core to our investigation as well. And it's all of these data lifecycle elements that contributed to our semi-structured interviews with the people actually working with data. And I'm using working with data to be extremely broad and to encompass all of these phases of the data lifecycle. So I said I would be brief. We have on the left-hand side of the poster a few of what we call the highlights, and then some specific insights are over on the right. Some of the highlights, particularly from a social science standpoint, are these. There are a lot of organizational values that find their way into the data lifecycle. And those organizational values influence the incentives for producing data and sharing data. By organizational values, I'll give you one particular example that came up repeatedly. The incentive to publish is something that all academics face. And the incentive to publish, and to publish as widely and as quickly as one can, leads to certain ways of handling data. We found, for example, that it leads researchers to, of course, privilege their self-interest over others' interests and to actually hang on to data for lengthy periods of time, lest they be scooped in their data use by somebody else. So this is an incentive of the academy that actually inhibits efficacious sharing of data. We also found, for example, that some of the organizational values that characterize a more proprietary sense of researchers over their data butts heads with other, especially younger researchers' sense of data. There was the observation that emerged in our interviews that older researchers have a more proprietary perspective to data, whereas younger researchers are more keen to collaborate and to share data and to believe that collaboration can create new things and that those will be better for the field. Second, highlight the platforms themselves actually have certain constraining practices. For example, a lot of data sets are held at computer sites, or in the case of the large repository Design Safe at the University of Texas, which has become a destination site for a lot of data sets. Those data are held at a supercomputer center, and that supercomputer really privileges security over just about anything else right now. It's a platform that is barraged by attacks constantly. So data security is first and foremost what they are geared to. And data sharing and sharing routines really come second or third or even fourth sometimes. Another finding that emerged repeatedly in our interviews has to do with this notion of open. All things open has a very positive sheen on it among academic researchers in particularly, and we privilege open data, open platforms, and open code as community efforts that allow us to better share what we're doing and to make use of what other people are doing. However, we found that a lot of the values that are inherent in this term open uh, fall apart when you poke them a little bit. And open doesn't always mean that the data will be complete or consistent or validated the way one might want them to be. And in fact, we have found that some data sets have different gradations of completeness, and in the interest of sharing and in being open, and perhaps in the interest of usability, the finer gradations and qualifications around data sets get a little glossed over by ultimate users who don't recognize or don't take the time to recognize some of the caveats around using certain elements of a data set. The researchers generating that data set may have done due diligence in declaring some of the limitations, but those limitations can be ignored and often are ignored by researchers reusing that data. So turning to that final column on the right, then, we observe that data quality in repositories can vary tremendously, and that attending to the fine print is extremely important in using repositories, both from the depositor standpoint and from the use standpoint, and that the ethical concerns often align with the community affected. To the extent that we want the ethical concerns, say around Harvey data, to align with the concerns of the people who were actually affected by Harvey, a lot of times those populations get lost in the actual data, and the data have a life of their own that becomes quite separated from the entities on whom the data are based. Open access technologies might not be as well understood by data users and creators as might be desirable. We also found that the future data use in AI or machine learning environments are not well understood, and people aren't really preparing their data sets with an eye to those particular applications. There's a wide variety of risks associated with creating these data, and in particular, there are risks built into sharing data that has some weaknesses or biases that could later be used for machine learning purposes. Finally, wrapping up, there are some real incentive issues that need to be dealt with, in particular, incentives within the academy for contributing to databases, for contributing to repositories, and taking the time really to render data sets to be used by others, to be cognizant and to have built-in features that minimize some of the ways that data can be misused. So I'll stop there and look forward to your questions in the question and answer session. Thank you.